Hello friends, welcome to Learner's Planet. Friends, this is our third session for coordinate geometry. In the previous session, we have discussed good number of problems from the topic. In this session, I'm going to take some more problems and I hope you had revised the previous two sessions before you are coming for this session. So let's begin this one. Now this question, if the coordinates of the midpoint of sides are this, find the coordinates of its vertices. So let's try this. Now what? This is point 3 minus 2 midpoint. This is point minus 3 1 and this is the point 4 minus 3. Now I assume the coordinate of vertices as x1 y1, x2 y2 and x3 y3. Now x1 plus x2 by 2 will be 3. That means x1 plus x2 is equal to 6. Similarly, x1 plus x3 by 2 will be 4. That means x1 plus x3 is equal to 8. Similarly, x2 plus x3 by 2 is equal to minus 3. That means x2 plus x3 is equal to minus 6. Now we have three equations and three variables. So we can solve and all the three equations we can get the value of x1, x2 and x3, right? First we take these two equations. I subtract this equation from this. So x3 minus x2 will be 2 and x3 plus x2 is equal to minus 6. That is already given. So if I add both of them, I'll be getting 2x3 is equal to minus 4. That means x3 is equal to minus 2. Right? Now if x3 is minus 2, if I put the value of x3 over here, if x3 is minus 2, x2 will be minus 6 plus 2, that means minus 4. So x2 is minus 4. Now if I put the value of x2 over here, I'll be getting the value of x1 as 6 plus 4, 10. Right? So this way we can calculate the values of x1, x2 and x3, and the similar manner you can calculate the value of y1, y2 and y3. Right? y1 plus y2 by 2 is minus 4, y2 plus y3 by 2 y2 plus y1 by 2 is minus 2, then y2 plus y3 by 2 is 1 and y3 plus y1 by 2 is minus 3. In the similar manner you can solve the three equations and you can get the value of y1, y2 and y3. Okay, I hope you are clear. Now in this question, find the area of the rhombus if its vertices are this taken in order. So let's do that. I draw a rhombus. Now this is 3 0 4 5 minus 1 4 and minus 2 1. Now what is the formula for area of rhombus? That is half d1 d2. That is half product of diagonals, right? Or what you can do, you can find out the area of this triangle and then double it, because both the triangles are similar or I can say congruent, right? Or you can go by this formula, half d1 d2. So this is d1 and this is d2, right? So let's calculate d1. d1 is equal to, d1 square is equal to 4 plus 2 square plus 5 minus 1 whole square, that's 16. So d1 square is 52. So d1 is root 52. Similarly, d2 square is 3 plus 1 4, 16 and this is 16. So that is 32. So d2 square is 32. So d2 is root 32. This we can say 2 root 13 and this we can say 4 4 root 2, right? So area will be half d1 into d2. So that is 4 root 26. Okay. Now let's see this one. The coordinates of the point on x-axis which are equidistant from points minus 3, 4 and 2, 5. Now since the points are on x-axis, y coordinate will be 0. So I assume that this point is x0, right? Now this point is equidistant from these 2 points minus 3, 4 and 2, 5. That means if we put up the distance formula, the distance between these 2 points will be equal to distance between these 2 points, right? So I assume this distance to be d1 and this to be d2. So precisely d1 is equal to d2, or we can say d1 square is equal to d2 square, right? So this is x plus 3 whole square plus 4 square is equal to x minus 2 whole square plus 5 square, right? So we just solve it. X square plus 6x plus 9 plus 16 is equal to x square minus 4x plus 4 plus 25. X square is cancelled. 6x plus 4x 10x plus 9 plus 16 25, and this is 25. So 10x is equal to 4. So x is equal to 4 by 10, or we can say 2 by 5. So x is equal to 2 by 5 and y is obviously 0. So the coordinates of this point will be 2 by 5 and 0. So that's none of these. Okay, I hope you are clear. Now in this question, find the area of the triangle whose vertices are. To solve this problem, we can directly use this formula. So that's half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2, right? Now here this I just write it x1 y1 x2 y2 x3 y3. So that is 2 3 minus 1 0 2 and minus 4, right? Now I put up the value x1, that is 2, y2 minus y3. So it's 0 minus minus 4. So 0 plus 4. So that's 4, right? y2 minus y3. Then plus x2. x2 is minus 1 into y3 minus y2. So minus 4 minus 3. y3 minus y1. So minus 4 minus 3. So that's minus 7. Plus x3, that is 2. y1 minus y2. So 3 minus 0. Okay. So that's half 8 plus 7 plus 6. So that is half 8 plus 7 15. 15 plus 6 21. So that is 21 by 2 square units. That is the area of the triangle. So nothing has to be done. You just have to put up the values of x1, y1, x2, y2 and x3, y3 in this formula. You can easily solve it. Okay. Now in this question, we have to find whether the 3 points are collinear. Suppose this is A, this is B, this is C. Now, if the 3 points are collinear, AB plus BC is equal to AC, or maybe AC plus BC is equal to AB. That means the distance between the 2 points, this plus this will be equal to this, right? Maybe they are in any other order, right? So what we do, first of all, we find out AB, BC and AC. So AB square will be 2 minus 1 whole square, that is 1 square, plus 3 minus 5 whole square, that is 2 square. So it is 5, right? So AB is equal to root 5. Now BC square is equal to 2 plus 2, 4 square, plus 3 plus 11, and that is 14 square, that is 196. So it is 196 plus 16, that's 212, so that's root 21. 2. BC is equal to, now AC square is equal to 1 plus 2, 3 square plus 5 plus 11, that is 16 square, so that is 9 plus 256. So AC is equal to root 265. Now this is root 5. This can be taken out of the square root. So this will be 2 root 53. And this is root 5 to root 53, and this can be written as 5 into 53. Right? Now here we can see AB plus BC is equal to AC, or maybe AC plus BC is equal to AD. Any of these, that means sum of the two is not equal to the third one, right? So these 3 points are not collinear. Okay. Now in this case, we have to find out the value of K for which the 3 points are collinear. So if the 3 points are collinear, then AB plus BC should be equal to AC. So we just have to put up the formula of distance formula over here. So here AB square is equal to 7 minus 5 square, that is 4, plus minus 2 minus 1 square, that is 9. So that is 13. That means AB is root 13. Now BC square is equal to 5 minus 3 whole square, that's 4, plus 1 minus K whole square. Okay, and the third one is AC square is 7 minus 3 square, that is 4 square, that is 16, plus minus 2 minus K whole square, or we can say 2 plus K whole square, right? So AB plus BC is equal to AC. So BC is equal to 4 plus 1 minus K whole square, and AC is equal to 16 plus 2 plus K whole square, right? Now we just have to put up the value, that is root 13 plus 4 plus 1 minus K whole square is equal to 16 plus 2 plus K whole square. Now you just have to square both the sides, and you just have to solve it to get the value of K, right? So this is a bit lengthy question, but if it is asked in examination, you can solve it in this manner. Okay. Now this is an important one. Name the type of quadrilateral formed, if any, by the following points and give reasons for your answer. Now we take this first one, A, B, C, D. Now AB is minus 1, minus 2. This is 1, 0. This is minus 1, 2. And this is minus 3, 0. So first of all, we calculate AB, BC, CD and DA, right? So AB square is equal to, this is minus 1, that is square, that is 4 plus 4, that's 8, right? BC square is equal to 1 plus 1 whole square, that is 4 plus 4, that is also 8. CD square is equal to minus 1 plus 3 square, that is 4 plus 4, that is 8. And then AD square is equal to minus 1 plus 3, that's 4, minus 2, 0 square, that's 4, that's 8. That means AB square is equal to BC square is equal to CD square is equal to AD square. That means all the 4 sides are same. So it may be a square or rhombus, right? In both the cases, as I've already told you in the previous session, in both the cases, all the 4 sides are of same length, right? Now we have to find out actually it is a square or a rhombus. What we can do is we can find out the length of the diagonal. If it is same, then it will be square. If it is different, then it will be rhombus. So for that, we take A and C and B and D, right? So AC square is equal to minus 1 plus 1 square, that is 0, minus 2 square, that is 4 square, that is 16. So AC square is 16. Now BD square is equal to 1 minus 3, that's plus 3. So 1 plus 3 square, that is 16. Now AC square is equal to BD square. That means both the diagonals are of same length. That means all the four sides are equal, both the diagonals are equal. That means it is a square, not rhombus. Okay, I hope you are clear. Now similarly we see this here, A minus 3 5, B 3 1, C 0 3, and D minus 1 minus 4. So calculate AB square, that is minus 3 square, that is 36, plus 5 minus 1 4 square, that is 16. So that is 52, right? Similarly BC square, it's 9 plus 4, because 1 minus 3 whole square, that is 4, so that's 13. Now CD square is 1 plus 3 plus 4 7, that is 49, so that's 50. And AD square is equal to minus 3 minus 1, that is minus 3, minus of minus 1, that is 4, plus 5 plus 4 square, that is 81. So it's 85. Now you can see AB square is not equal to BC square, is not equal to CD square, it's not equal to AD square, right? So which type of quadrilateral it will be? It will be a simple quadrilateral, neither a rectangle nor parallelogram, no square and no rhombus. Okay. Now similarly we see this A 4 5, B minus 7 6, C 4 3, and D 1 2. So we calculate AB square, so that is 4 plus 7, that is 11 square, 121, plus 5 minus 6, that is 1 square, so that is 122. Similarly BC square is equal to minus 7 minus 4, so that is 121, 6 minus 3, that is 3 square, that is 9, so it's 130. Then CD square is equal to 4 minus 1, that's 9, plus 3 minus 2, that's 1, so that's 10. You can see AB, BC, CD, no, none of them are equal. Similarly we can calculate DA square also. So 4 minus 1, that is 3 square, 9, plus 9, so that's 18. So AB is not equal to BC, is not equal to CD, is not equal to DA, right? So once again, it is not rectangle, this parallelogram, this rhombus and square. Okay. Now this question, find the values of y for which the distance between the points is 10 units. So PQ is equal to 10, that means PQ square is equal to 100. Now we use the distance formula. So 10 minus 2 whole square, that is 8 square, plus y minus minus 3, that is y plus 3 whole square is equal to 100. So y plus 3, y square plus 6x plus 9 is equal to 100 minus 64. So y square plus 6x plus 9, 100 minus 64 is 36. So that's minus 36 is equal to 0. So y square plus 6x minus 27 is equal to 0. So that is y plus 9. I'm sorry, this 6y actually. So that is y plus 9, y minus 3 is equal to 0. So y is equal to minus 9 and 3, right? So we have two values of y is equal to minus 9 and 3, for which the distance between these 2 points will be 10 units. Okay, I hope you are clear. Now, this problem, if Q is equidistant from P and R, find the values of X. Also find the distance QR and PR. Once again, the similar question. QP is equal to, Q is equidistant from P and R, that means QP is equal to QR, or we can say QP square is equal to QR square. So first of all, let's find out QP square. So that is 5 minus 0 whole square, 25, plus minus 3 minus 1 whole square, that is 16, is equal to QR square is X minus 0 whole square, plus 6 minus 1, 5 whole square, that is 25. So x square is 16, that means x is equal to 4 or minus 4, right? Now we have found out the value of x. Now we have to find out the distance between QR and PR, right? So QR, just put up the value of x as 4 or minus 4 and just use the distance formula and get the distance between QR and PR. Okay? It's simple to do. Just have to apply the formula directly. That's why I'm not solving it. Okay? Now find the relation between x and y such that point this is the equidistance from these two. Suppose this is P, this is Q, and this is R. That means PQ is equal to PR, because XY is the distance between P and Q is same as the distance between P and R, as it is given that the point is equidistant from the points this and this, right? That means PQ square is equal to PR square, right? So PQ square is what? X minus 3 whole square plus y minus 6 whole square is equal to PR square. That means x plus 3 whole square plus y minus 4 whole square. Okay? So x square minus 6x plus 9 plus y square minus 12y plus 36 is equal to x square plus 6x plus 9 plus y square minus 8y plus 16. Okay, just have to simplify it. X square is cancelled, y square is cancelled. Now we take all the data at one side. This 9 and 9 is also cancelled. So this is 6x and 6x, 12x. Then this is minus 8y plus 12y, so that's plus 4y plus 16 minus 36 is equal to 0. So 12x plus 4y minus 20 is equal to 0. I can take 4 as common. So 3x plus y minus 5 is equal to 0. That is the relationship between x and y. Right? So that's pretty simple. You just have to use the distance formula. PQ is equal to PR. That means PQ square will be equal to PR square. Right? And just simply solve it. You will be getting the relationship between x and y. Okay? Now this one. Find the coordinates of point A where AB is the diameter of a circle whose center is 2 minus 3 and B is 1, 4. Now A and this is B and this is center. Right? This is 2 minus 3 and this is 1 and 4. Now obviously the midpoint of diameter is center. That means if we are having the coordinate of B and coordinate of center, then we can easily find out the coordinate of A, right? Because x1 plus 1 by 2 will be equal to 2, because this is the midpoint. So x1 is equal to 4 minus 1, that is 3. Similarly, y1 minus plus 4 by 2 is equal to minus 3. So y1 is equal to minus 6 minus 4, or we can say y1 is equal to minus 10. So the coordinates of A will be 3 and minus 10. Okay. The only important property that we have used over here is the center point of the diameter is this midpoint of the diameter is center. Okay, so this plus this by 2 will be this. Okay, that's it. Now this question, find the coordinates of the points which divide the line segment A and B into 4 equal parts. I just draw the line. Now this point is minus 2, 2, and this is 2, 8. Now 4 equal parts, that is 1, 2, and 3. So this is equal to this, is equal to this, and this, right? So this is A, this is B, this is P, Q, and R. So AP is equal to PQ is equal to QR is equal to RB, right? AP is equal to PQ is equal to QR is equal to RB. That means AP is to PB will be 1 is to 3. That means P divides A and B in the ratio 1 is to 3. So that is M1 is to M2, right? So M1, M2 we are having, X1, Y1, X2, Y2 we are having. X1, Y1 is minus 2, 2, and X2, Y2 is 2, 8, right? So we are having the ratio in which P divides the line AB into ratio 1 is to 3. We are having the coordinates of A, we are having the coordinates of B. So we can find out the coordinates of P. So that is X, that is M1, X2. So M1 is 1, X2 is 2 plus M2 X1. So that is 3 into minus 2 upon M1 plus M2, that is 4. So this is 2 minus 6 by 4, that is minus 1, right? Similarly, we can calculate Y, that is M1 Y2. So M1 into Y2 is 8 plus M2 into Y1, that is 2 upon M1 plus M2. So that is 8 plus 6, 14 by 4, or we can say 7 by 2. So the coordinates of P will be minus 1 and 7 by 2. Minus 1 and 7 by 2. Right? Now this distance is equal to this distance. So this should be midpoint of AQ, right? That means AP is equal to PQ. So we know this, we can calculate this, right? So suppose this is say L and M, right? So L minus 2, I just write it over here. So Q will be actually midpoint of, P will be midpoint of AQ, or we can say actually Q will be midpoint of A and B, right? AB, right? So L is equal to minus 2 plus 2 by 2. So that's 0, and M is equal to 2 plus 8 by 2, that is 10 by 2, that's 5. So coordinate of Q will be 0, 5. And similarly, we can find out the coordinates of R. 0 plus 2, midpoint of these two will be R, right? So suppose this is say A, B, that means A is equal to 0 plus 2 by 2, that is 1, and 5, B is equal to 5 plus 8 by 2, that is 13 by 2. So we got the coordinates of P, Q, and R, all of them as well, right? So that's pretty simple but an important problem. So just revise it once again, okay? So friends, we'll be discussing more problems on coordinate geometry in our next session. Do revise this session before you come for the next. Bye-bye.